Hey there, today we'll be doing the third day's problem, that is from the graph playlist of Leetcode that we are doing. And the problem is, first we'll be doing number of enclaves, and then we'll be doing count sub-islands. And the day 2 and the day 1 have already been completed and also been uploaded. Please do check it out. That will help you understand these questions that we'll be doing in the following days. And also right here will understand better. Okay, so now coming on to the question, that is number of enclaves 1020 lead code. And the question states that you are given an m cross n binary matrix grid where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent four directionally, and we need to return the number of land cells in grid for which we cannot walk off the boundary of the grid in any number of modes. So what is this question trying to tell us? This question, just in a simpler manner, if I explain it, this says that all the ones that are completely enclosed and cannot reach the boundary anyhow by moving four directionally, you just need to return me those number of ones. That is, let's just say, let's just consider this as one as countries. Okay, so these are landlocked, and why so? Because it cannot reach these boundaries. So these boundaries right here, be it 1, be it 0, whatever be it, you cannot just go on to the boundary. Just think of it as a border. So from this one right here, okay, you can go here as well as here, but you cannot go anywhere to the boundary. So the number of ones, or the count of ones which can only go within themselves and not onto the boundary, is 3. So that is what you need to return. But mind you, if there was something like this, what would have happened? From this, obviously you can go here, fine, but from this one you can also go to this, and thus you'll be reaching a boundary. So just saying that we cannot reach this, okay, and this is not possible right here, so we'll need to return a 0. So by any means, if you can reach the boundary cells, you just need to return a 0. Otherwise, just return the number of cells in the matrix that are left out after doing this operation. Okay, so basically you just need to do what? You just need to do a DFS. But how? I'll be giving you a hint first, and then automatically an idea will come to our mind. The hint is that first we can do a DFS from all the boundary elements, and I think the idea must have struck you and you are going into the right direction. And the idea is that we'll be doing the DFS on all the boundary elements, and it will help us what? It will help us through marking all the cells from where we can reach all the inner elements. And this concept has been used in which question? This question right here. Some Pacific question was there. I don't remember that question right here. The Pacific Atlantic flow, water flow. This type of question will also be used. Okay, in this question, the concept is exactly similar to Pacific Atlantic water flow, which we'll be doing tomorrow. So please do watch this video carefully because the types are similar. Okay, so what will happen is, if you do a DFS from here, what will happen is you'll start and you'll try to mark on. Let's just say there is a 1 right here. If you start a DFS from 1, the basic simple DFS that we do, what will happen? All of these will be marked. Okay, now all these will be marked as, let's say, 0. Fine, that means you cannot reach them anymore. Now after that, what you'll do, you'll just check that are there any ones left? Obviously not, so you'll return a 0. But let's just say this is your matrix right now, that is the given one. You start your DFS from where? From every boundary cell only, right? All the boundary cells only. Now where do you get 1? You start a DFS from there. You start a DFS from here. And do you find anyone other than that? Obviously not. So do not worry about any other thing. Just start your DFS from here. Now, can you go anywhere else other than this position? Up, left, right, down. And mind you, this is technically, or you cannot go out of bounds. So that is not a possible move. You can only go in bound elements or cell. Fine. So if you can, let's just say, go up, you'll go up right here and you'll mark this as visited. You'll say that, okay, from this boundary cell I could reach these guys right here, and you'll make sure that these are marked visited. Okay, after this is marked visited, there is no use of those cells. So now what you will do, you'll just count on the remaining ones that you have. So now as I've discussed the whole algorithm, let's just see the code. The code is very simple, it is not that big, and if you have been following this pattern, that is how we iterate on the up, down, left, or right pattern, you'll understand this video in a much simpler way. And if you did not, please do check out the previous videos. I've explained how this works. Okay, so coming on to this question, what are we doing? We are just doing a DFS from all the corners and all the up, left, right, and bottom rows. And what do you mean by that? All these volumes that I've written, what are they doing? They are doing the DFS from here and here first. After this is done, I'm doing the DFS from the first column and the last column. Okay, so this is what it's doing. Fine. After the DFS is done, what is happening? Everything is marked as 0 from wherever we can reach. So this is a simple code that we wrote. Okay, for all the given positions that are having 1 in the rows of the first row and the last row, we are doing a DFS, and all the given values which have 1 in the first column and the last column, we are doing the DFS. Now let's see the DFS function. Now this is the simple plain old DFS that we have been writing from day one. Okay, and what do we need to take care of? Here we just need to take care of that we do not go out of bounds, which is being written here, and the value has already not been visited. If it has not been visited, we'll go visit them. And I see that, okay, I'll just come on to the example again to explain this better, and I'll just modify this as well. Let's just say this is your value, fine, and you are starting your DFS, sorry, from here. Now what will happen? You'll go down, okay, and you can go right. These are the two possible moves. So what will happen? These two guys that you have visited will be marked what? Will be marked 0. Okay, so these two guys will be marked 0. And how will that be marked? This is the condition that we are writing, that if I can go to some position to the right, left, up, or down, we'll do what? We'll just mark that grid to be 0. And mind you, I'm changing the uh, grid that has been given in the question itself. Okay, I'm not taking any extra space. You can also use an extra visited array, that is up to you, totally fine. Okay, so once I have visited this, what am I saying? I'm marking this as 0. So this becomes 0, 0, and 0. Now from these two guys, can you go anywhere? Obviously not, you cannot go anywhere, right? So this is how your new grid looks like. Okay, and why it will look like this? Because we are only iterating on the edges of the matrix. Okay, remember this fact. And at the end of the day, what do we do? Whatever is the count of ones in the matrix, we just return that. That is our answer, as simple as it can get. Okay, so this is the DFS, a very simple one. And what do we do at the end of the day? We just count the number of ones. So this is counting the number of ones, and this will return whatever the number of ones that are left present there. And I've already submitted this code, no need to worry about that, and the code will also be in description. Okay, and if you still have any doubt, please do ask me in the comment. And yeah, thank you for watching, and if you did understand this